Hi everybody, this is Mo Quant, and today I'm going to be showing you how to animate the gradient descent algorithm in C++. And the way that we're going to do that is by coming to this library called Matplotlib-CPP, which is made by someone named Lava. And let's go through this README real quick. So we can see we just called matplotlib-cpp.h. We can change the namespace to plot so it's easier to call the functions. And this creates a simple 2D graph, and this is how you compile the code. And we're going to be using Python 3.10 instead of 2.7 in our example because that's what I have installed on my computer. So let's just scroll through this. Okay, we can do multiple lines. They can do a heart sign, sine wave, differential equations, and 3D and plot. I almost said animation. So that's the issue with this library. The 3D plot function is programmed to where the figure renders on each iteration. So if I want to plot, let's say, 100-point animation, it's going to generate me 100 3D plots, and I don't want that. So what I'm going to do now is I'm going to come here, I'm going to fork it into my own GitHub, and it's loading. Let me move this down here. Okay, so I successfully forked it. So now I'm going to come to code, copy the URL, and clone it onto my desktop. So I'm going to do cd desktop git clone control shift v, and I'm going to call this folder mx. Okay, so it cloned into mx. Now let me minimize these two, and I'm going to open Visual Studio Code, and I'm going to drag this folder into there, mx. Oh shit, I don't like all this. Okay, shit, why is this not working? Okay, so MX is loaded. Okay, so now let me make this big. What I'm going to do first is I'm going to create a new file, and I'm going to call it algo.cpp. So we have algo.cpp. Let's also open up matplotlib-cpp.h. And I'm going to do the same thing. I'm going to do include iostream, include vector, include string, include python.h, include matplotlib-cpp.h. Now I'm going to do namespace plt equals matplotlib-cpp, which is the namespace name. And I'm going to do int main return 0. Okay, so first things first, let's get right to the 3D plot. So what we want to do is first we need to let's see. So pyplot is the main library that we need, matplotlib.pyplot, and it loads as pymod, but I want to declare this variable somewhere else. So I'm going to hit Control X. I'm going to come all the way back up here, and I'm going to create the first function, pymod. So this will allow our variable to be global, and we can call it anywhere in the namespace. So now I got that set. The next thing I'm going to do is actually maybe okay, I want to come down. There's a plot surface function in here that I need to modify, or rather just create like a new one. So here's the plot surface one. So I want to copy these, but like make some changes. So I'm going to come up here to my interpreter, and let's see where we call pymod. Okay, so right after pymod, I'm going to add a lot of space, Control V, but I'm going to have to delete some of these, so we don't need static, and it doesn't need to be a null pointer. PyObject, let me add a space between them, get rid of that. We don't need the detail interpreter.get, that's going to crash our program. So we import MPL toolkits and mplot3d, and oh no, we just declare them as string to object. So we do pyimport MPL toolkits and pyimport axis3d. So let's go ahead, and before we get too far ahead in this, let's let's compile this. So in order to do that, we do g++ algo.cpp, which is the C++ file name, a minus std equals C++11, because in order to use vectors, we have to use C++11 or greater for it to work. And what is this shit? I hate these little extensions in Visual Studio Code. Like, they're really annoying when I'm trying to make a video. But I'll do the minus sign again and do I user include Python 3.10 and Python 3.10. And now I do a.out. Okay, so everything ran. It's not really causing an issue. So what I want to do now is, so I got pymod. Yeah, I got pymod made as a variable. So if I come down here, I could do. So wait, this is the detail namespace. I think I should make this outside of it. Yeah, I think I should do that right in here. So that'll be PyObject chart int place. So PyObject draw object equals PyObject get adder string. Oh right, I need another argument in here. PyObject ax, which is gonna be the. Actually no, I don't need a. Oh yeah, this is where I call pymod. So in order to do that, I get detail interpreter get pymod, and what I want to do is add subplot. Okay, so I get that. Now what I want to do is create arguments, which is a new pytuple, and it's only going to have one argument in it. And then I need my kwargs, which are parameters. Oh no, I don't want that. Pydict new. So now pytuple, I'm going to add items to this. Set item args 0 pyfloat from double place. Oh no, it's going to be pylong from long place, and pydict set item string kwargs projection pyunicode from string 3D, and pyObject the plot is going to equal pyObject call draw object args and kwargs and return the plot. Okay, so now we got these. Now I can come over here and I can do plt chart. Oh no, I'll do pyObject ax equals plt chart 111 and plt show. So now let me recompile this. A.out. Perfect. No errors. We got the chart loaded. So that's all we need to do now in terms of this one. Well, actually, we need to add a clear function as well. So that's going to be, should I do a inline void? Yeah. Inline void clear 3D chart pyObject ax. So now what we could do is pyObject eraser equals pyObject get adder string ax cla, and this is only going to need an argument list. So args equals pytuple new 0, and now we could just simply do pyObject call object, because we don't have the kwargs, eraser and args. So let me come over here and do plt clear 3D chart ax just to make sure the function worked. Okay, so it gave me a weird error. Oh, I forgot the pointer. Okay, so now this should work. Yep. Yep, it cleared. Or it didn't say any error, so I assume it works. Okay, so now that we got that, we need to create the surface plot. And for that, I'm going to come down to the actual surface plot in here. I'm going to copy this same function. But I'm going to go over here, close those off, and change the arguments a little bit. So pi object ax, we keep the x, y, and z, but for the last arguments, what we're supposed to do is I'm going to have this as a color. So string color and double line width. Yeah, I think I'll just keep it like this. And I have x, y, z, so pi object x equals detail get 2D array of x, pi object y equals detail. This is simply converting like the C++ code to Python. So detail.get 2D array y, and pi object z equals detail get 2D array z. Okay, so we got that loaded. So now we need pi object arguments equals pi tuple new, and it's going to take 3 arguments, and then we need a dictionary as well. kwargs equals pi dict new. So pi tuple set item args 0 big X, we're passing the arguments through, args 1 y and args 2 z, and now pi dict set item string kwargs color pi unicode from string color dot underscore c str, and another argument line width pi float pi long from long, and that's going to be line width. Okay, so we've got our arguments in. So what now is to do pi object the plot equals pi object get adder string ax plot surface, and pi object pi object call the plot args and kwargs, and I think we have it done. I'm going to rename this to surface 3D, and now okay, I'll show you once it works, but now I've got to create some parameters. So I'm going to come here and let me define my f of x function. So double fx, which takes double x, double y. And let me also make sure I imported math as well. So include math.h. So I'm going to come here and do return the power of, it's going to be negative x squared plus y squared. So I'm going to define some functions here. So double t0 equals negative 4.0 and t1 equals 4.0, and double dt equals t1 minus t0 divided by, oh right, we need an n variable, int n equals 60. I'm going to make this big just for the quality. It's going to be n minus 1 as the denominator. So now what I could do is define my vectors. I'm going to define a double vector, 2D vector, I mean x, y, and z, and I'm going to define a single vector, tx, ty, tz. Now what I'm going to do is I would define double rx and ry. You'll see what these do in a minute. So I do for int I equals 0, I is less than n, plus plus I. I'm going to clear the vectors here, so clear, clear, clear. And now for int j equals 0, j is less than n, plus plus j. So our rx variable will always be t0 plus I times dt, and our y variable will be t0 plus j times dt, just so I don't double call them for like memory purposes. But what I'm going to do now is I'm going to do tx dot pushback rx, ty dot pushback ry, and tz dot pushback f of x of r of x, r of y. As shown in the function right here, it just takes an x and a y and returns you a value. And then I'm going to come down here, and what did I call it? X, y, and z. X dot pushback tx, y dot pushback ty, and z dot pushback tz. Okay, so we've got our function. Now let's go ahead and plot it. So I need to call this function surface 3D. So plt surface 3D ax x y z red, and 0.9 is the line width. Now let me go ahead and compile it here. I'm going to be very shocked if I don't have an error. Oh wow, I don't have a single error in that, so I hit a dot out. Okay, so this is our function, negative x squared minus y squared. So what I'm going to do to test this out, to make sure that I can overlap plots, is I'm going to do plt surface 3D ax x z y, make it blue, 0.9, just to show that it could show up on the same plot. Okay, perfect. So now we don't need, so I fixed the rendering issue with this library, where now we can animate functions without having it call its own instance. So now that part is done. Let's see, got that done. Let me check out the clear function. So plt.clear 3D chart ax. So nothing should come right now if this function truly worked. A dot out. Perfect. So everything works now. So now we can go to the animation. So in order to do that, so it's going to be gradient descent. I'm going to pick random points. So double px equals negative 3.5, py equals negative 3.5. So these are our initial parameters. Maybe what I should do is make a plane function. Yeah, I need to make a plane. So I'm going to come up here, and I think we may... Oh, first I got to do the derivative. So double dfx double x double y. So that just returns negative 2.0 times x, and double, I'm just including the variables to avoid confusion, but double x double y return negative 2.0 times y. Okay, so these are the derivatives. Now I need to let's see. Okay, so double plane is gonna take an argument of x and y. So I believe now the plane function is, oh right, I need double x0 and double y0. It needs to have a center point. So that will simply be dfx of x0 and y0 times x minus x0 plus dfy of x0, y0 times y minus y0 plus f of x0, y0. Okay, I believe that's the plane function. Now, I want to, let's see, okay, I think I know what to do. So double, I'll call this tangent. We may need to input the vectors into here. So std. Oh no. We're just going to double x0, double y0. Let me think. This is how do I do this? Double C. No, okay, I may have to call the vector. So std. No, it's oh, I see. Yeah, so I only do int c. So int c. No, double c. Double x. Or no. Double t0 and double t1. Or no, x0 and double y0. Okay. So now double m0 equals x0 minus c, and m1 equals x0 plus c. We're going to make this a grid. n0 equals y0 minus c, and n1 equals y0 plus c. We'll make n again equal to, we'll call it O this time. We'll make O equal to 60. And then, oh, I see what we'd have to do. We need a map. Yeah, we need a map for this. So std map, std string, std vector, vector double. Okay, so include map. Now we could do the fun part. So we could define our map, or I'm just going to copy and paste it from here. And I'm going to call it result. And I'm going to make some sample vectors. Same thing, tx, ty, tz. And what it's going to do for int I equals 0. I is less than O plus I. tx.clear, ty.clear, and tz.clear. And I'm going to make the same double rx and ry. So rx is going to equal m0 plus I times I never oh shit, my mistake. Before I do that, I gotta define like dx and dy, so double, I'll call it dm and dn, so double dm equals m1 minus m0 divided by O minus 1, and dn equals n1 minus n0 divided by O minus 1. So now what we could do is do Rx equals M0 plus I times dm, and for int j equals 0, j is less than O plus j, ry equals n0 plus j times dm. Okay, perfect. So now we can get the vectors. So tx dot pushback rx, ty dot pushback ry, and what did I define c as? Oh, we haven't defined C, so TZ is going to be, what do we call it up here, plane. So it's going to be plane of r of x, r of y, x0 and y0. Rx, Ry, x0, y0. And then we're going to come down here and we're going to do result x dot push back tx, result y dot push back ty, and result z dot push back tz. And we can come down here and return the map. So we return result. So this function is called tangent. Now what I'm going to do here is I'm going to define a map. Or maybe, yeah. I'll call it GD. So now for while true, so our px is going to, oh wait, let me define a learning parameter. Double learning equals 0.01. So these are the points we're going to start off with, and instead of a while loop, I'm going to do for int I equals 0. I is less than 100 plus I, just so it can end. I don't want to put it on an infinite loop yet, but now what I could do is, did I make the function up here? Yeah, dfx and dfy. So it's going to be px equals px minus learning times dfx of px and py. And py equals py minus learning times dfy of px py. Okay. So now what I do is I immediately call plt clear 3D chart ax, and then I do gd equals should I forgot tangent, yeah, tangent, and it's gonna have a span of 0.7. That's gonna be the plane. So now I do x0 and xy, which is px and py, and then I do plt surface 3D of our regular x, y, and z. Oh no, let me put, okay, so ax, x, y, z. I'm gonna make this red and 0.9 line width. And plt surface 3D ax gd of x, gd y, and gd z. And I'm going to color this green and make the line width the same, 0.9. So now what I want to do, I want to come in here and do plt pause for 0.1. Let's pause for half a second. So I hope this has no errors in it. Perfect, no errors. And I do a dot out. Oh, I see what I messed up on. I got to add it because it's already a negative. So, and I'm gonna lower the, maybe I should raise the learning rate to 0.07. Let's see if this looks better. Compile that, reset that, a dot out. Okay, so I see it moving. Oh, I understand what I have to do now. I gotta make this equal to 1.5 because we're doing -4 to 4. So the plane will show up. Maybe what I'll add here is another argument, dict set item string kwrgs alpha long from long alpha, and I'm going to pass the alpha as an argument. So line width double alpha. Okay, so the alpha for the red curve is going to be 0.65, and the alpha for the green curve is going to be 0.95, because I want to see the green one. So let me I'm going to hand compile it. So g++ algo.cpp std equals c++11 I user include Python 3.10 and L Python 3.10. Okay, now do a.out. Damn. Let me just get rid of that. That was not a smart decision. But okay. Let me compile it again. Okay, so now we can see the plane going, like it's reaching the optimal point. And this is how machine learning works. This is the algorithm called gradient descent. Well, in this case, it's gradient ascent. But yeah, it found it. I'm going to do one more run of it. I'm going to do 2. And I'm going to make the learning rate 0.15. And then, yeah, we'll be done with this video. So reset that. Compile it one last time. And yeah, there you have it. This is basically how machine learning works under the hood, but a much more complicated version of this. But yeah, I hope y'all learned something from this. I enjoyed making it. It's just like standard algorithms, simple calculus, and yeah, hope y'all enjoyed watching my video. Peace out.